This is a video about finding x and y intercepts. So first you need to understand what x and y intercepts are. So an x-intercept is where a graph crosses the x-axis. So in this case, that point would be right here. So that point right there would be the x-intercept. If the line was over here, then this would be the x-intercept, etc. So wherever it crosses that x-axis, that's the x-intercept. And there's something special about every x-intercept. Every x-intercept has a y value of 0, because in order to cross this line, in order to hit the x-axis, you can't go up or down any. So when you're plotting that point, it has to be left or right, how many ever, and then you can't go up and down at all. So that y value has to be 0. Otherwise, you wouldn't be on the x-axis and you couldn't be an x-intercept. So that is the special feature for x-intercepts. That's when y is equal to 0. So we can use that fact to help us by plugging in, if we have an equation for that graph or a line. Lines are what we're dealing with right now, but for any graph, if you plug in 0 for y, you can find the x-intercept. Same thing goes for a y-intercept. So for a y-intercept, that's when x equals 0, because in order to hit this y-axis, you can only go up or down. When you plot a point, you can't go left or right first, because then you won't be on the x-axis. If I go right 5, I meant y-axis, but I'm no longer able to be on the y-axis. I have to stay at an x value of 0. So because of that, for every y-intercept, the x value is 0. And again, that's nice because we can, again, plug that into the equation, and then we can figure out what the x-intercept is. And that's why for a slope-intercept form, like for y equals 3x plus 2, that's why this is the y-intercept. Because when we plug in 0 for x, that zeroes out this term, so that term is no longer there. And then y equals 2. So that would be solving for the y-intercept. That's what it would be. So that's a definition of x and y intercepts. So now let's find some x and y intercepts using an equation. If it's on a graph and you're not given an equation, then you just estimate, like this one that I drew here. We just have to estimate that x and y intercept there. But if you're given the equation, you need to find the exact x and y intercept. Now if you have the graph and an equation, and the graph is nice to us, and it crosses at a really nice point, like pretend that crossed right at 5, then you can take it off there. But if you're ever unsure, then you need to use the equation. And so that's what we're going to do in this video. Our first example is y equals 3x plus 2. So let's find the y-intercept first, because that's easy. This is in slope-intercept form, so I already know my y-intercept is 2. But I'll show you plugging in as well. So if we actually plug in 0 for x, we can solve for y, because we know that that xy pair satisfies the function. When x is 0, what is y? That's what we're looking for. So y equals 0 plus 2, which is just 2. So that is your y-intercept. Now the x-intercept is a totally different point. It's not part of the same point. A lot of people like to write the x and y-intercept, like say the x-intercept's 3. They would write 3, 2. That makes no sense at all. They're two different points. This actual point for the y-intercept is 0, 2, because I plugged in 0 for the x-intercept. So now for the the y-intercept I meant. Now for the x-intercept, this isn't as easy when it's written in slope-intercept form. We plug in 0 for y, so it's 0 equal to 3x plus 2, and we're going to find out the x value that would make the equation equal to 0, or have an output of 0. So simple, straightforward equation. Subtract 2 and then divide by 3, so x equals negative 2/3. So this graph, y equals 3x plus 2, will cross the x-axis at negative 2/3, 0. And it's obviously 0 for the y-axis, otherwise it wouldn't be crossing the y-axis. So that's the actual point. But we say x-intercept is just negative 2/3 because we know that the y value is 0. We don't have to say that every time. And so that's the x and y intercept of this graph. And what we can do now is actually graph this equation using the x and y intercept. So if you just plot those 2 points, you can graph a line. In this case, it would be easier to just plot the y-intercept and use the slope, since we know that already, and since the x-intercept is not a very nice number. If it was a nice number, then fine. Plot this point, well, this point and this point, and then draw a line, and that's your line. You don't need any more points than that. Let's do another one. For this example, we have another equation in slope-intercept form, so we already know what the y-intercept is. The y-intercept is 4. So that means we've got a point on our graph 0, 4. And then the x-intercept, we're going to plug in 0 for y, so we know that y is equal to 0. So it's 0 equals negative 2/5 x plus 4. Need to get the x term alone, so subtract 4 from both sides. Equals negative 2/5 x. Now to get rid of that, we do want this to be 1 this time, so I'm going to multiply by negative 5/2. Multiply by the reciprocal, and then that's really negative 4 over 1, so negative 5 times negative 4 is 20, 20 divided by 2 is 10. So as x is equal to 10, so that means the x-intercept is 10. So the point 10, 0 is on the graph because the x value is 10, the y value is 0. Now let's graph this since we had two nice points. So when we graph it here, we're just going to graph those 2 points. 10, 0. And change the thickness of my line here. A little too big. Okay, and negative 10, 0, and then the other one was, don't remember, 4. So 0, 4. And now we can just draw a line through it. And that would be your line. So it's not the straightest line, but it'll work. And so that's it for that one. So you can easily graph it if you know the x and y intercept. Now it was a little difficult because we were in slope-intercept form rather than standard form. Standard form is easy to find both x and y intercept, and then that makes it easier to graph too if you just have those 2 points. But again, if they're not nice points, it won't look that nice. Let's do another one where it's in standard form. This example is 2x plus 3y equals 12, and this time we actually do need to plug in for both of them to find out the intercepts. So for the x-intercept, again, that's when y equals 0. So this is how I want you to write it. Write y equals 0 right underneath, so I know what you're doing. So 2x plus 3 times 0 is equal to 12. And then, so that's just 2x is equal to 12. Divide each side by 2, and x is equal to 6. So that means that the x-intercept is 6. So a point on our graph is 6, 0. Now let's find the y-intercept, and that's when x equals 0. So we're going to plug in 0 for x into the equation. So 2 times 0 plus 3y equals 12. Then that's just 0, so it's 3y equals 12. Divide both sides by 3, and y equals 4. So that means the y-intercept is 4. And that means the point 0, 4 is on our graph. Let's graph this too, since we had 2 nice points here. Now we can graph it. And I went ahead and graphed it, so we have a y-intercept of 4, an x-intercept of 6, and so there's 2 nice points. Draw your line, and just note that it has a negative slope. If you did not want to graph, like if I asked you just to graph the line, this line, you could do this, find x, y-intercept, be done, draw 2 points, plot those 2 points, draw the line, or you could have taken this equation and rewritten it in slope-intercept form, which is in another video if you're having trouble with that. But once you write it in slope-intercept form, it would be y equals negative 2/3 x plus 4. And then so our slope is negative down 2 over 3. And we can see that that's actually doing that. It's hitting down 3, or down 2 over 3, down 2 over 3. And so you could have graphed it like that too if you didn't want to graph it this way. Let's do another example where it's not where both of the intercepts are not nice. And it's written in standard form. This example, 7x minus 2y equals 15. To find the x-intercept, we are going to, again, plug in 0 for y. So y is equal to 0. So 7x minus 2 times 0 equals 15. So 7x equals 15. Divide by 7. X is equal to, you can leave it as 15/7, or it's 2 1/7. And so that's your x-intercept. So that means the point 2 1/7, 0 is on our line. So that's not a very nice point. But that's okay because we're not going to graph it anyway. But there are some that maybe it's going to be that ugly and you are going to have to graph them. So it's okay. But for our purposes here, we're just going to find the intercepts. So the y-intercept is when x equals 0. So 7 times 0 minus 2y is equal to 15. So that's really just negative 2y equal to 15. Divide by negative 2. And y equals 7, negative 7.5. And you could leave it as 15/2 if you want. But it's really negative 7.5. And so that means your y-intercept is negative 7.5, which means the point on our graph is actually 0, negative 7.5. And that would be the x and y-intercept for that line. Let's do one more with some fractions. Let's find the x-intercept and y-intercept for negative 1/2 x plus 4/5 y equals 2/3. If you don't like the fractions right away, we can get rid of them right away by multiplying by the least common multiple of their denominators and getting rid of all the fractions, but I don't want to do that. So I'm going to do x-intercept is when y equals 0. So you got negative 1/2 x plus 4/5 times 0 equal to 2/3. So it's really just negative 1/2 x equal to 2/3. To get rid of times in by negative 1/2, you're going to divide by negative 1/2, which is the same thing as multiplying by negative 2. So multiply each side by negative 2. Then you get 1x on the left side, and 2/3 times 2 is 4/3, but it's negative, so it's negative 4/3, or negative 1 1/3. So the x-intercept is negative 4/3. So that means it goes to the point negative 4/3, 0. To find the y-intercept, we're going to plug in 0 for x. So x is equal to 0. So then our equation is negative 1/2 times 0 plus 4/5 y is equal to 2/3. And then, so that's really just 4/5 y equal to 2/3. And to get rid of times by 4/5, we're going to multiply it by the reciprocal to make it 1. So multiply by 5/4. So on the left side is just 1y. And then 2/3 times 5/4. Remember, when you're multiplying fractions, you multiply across. You can cross reduce here if you'd like. So that'd be 1, that'd be 2. And then now multiply across is 5/6. Because it would have been 10/12, which reduces to 5/6. And so it's y equals 5/6, and that's your y-intercept. So the y-intercept, I don't have room to write this. The y-intercept is 5/6, so that means the point on our graph is actually 0, 5/6. And that's it for that one. Now I'm going to do a couple examples where you're going to pull, well, no, but if you're pulling a x and y intercept off a graph, all you have to do is look at it and then estimate it if you're not given the equation. If you are given the equation and the graph, you need to use the equation unless it's blaringly obvious that it is something. And that would have to be where a lattice point where it crosses at a nice point. Otherwise, don't estimate it. Use the equation if you've got it. So that's it for finding x and y intercepts on linear equations.